I'm here in the lowlands of northern Switzerland, and if I look at the horizon, I can see the Alps and I see some glaciers, and there we can actually study processes related to glaciations, to the ice-rock interactions. This is also a nice landscape here, and in fact the hill behind me has also been shaped by ice. And during the last glaciations 20,000 years ago, this glacial hill, this all formed, and we can study also the processes that we see today in the Alps here in the lowlands. However, 20,000 years ago was the last ice age, but that wasn't the only glaciations that occurred. We know that in the last million years, about every 100,000 years, we had the glaciers advancing from the Alps and then again melting and retreating back into the mountains. But we don't know exactly when that occurred, how far the glaciers reached out, so the knowledge of these old ice ages is rather limited. Now, we have very good witnesses of these old ice ages, but they are hidden. Below the ice, the glaciers can make deep troughs. They erode deep into the basement rocks, and these troughs, these overdeepenings, are afterwards filled with sediments. But we don't see the sediments at the surface, and this is why back in this forest we drill into such an overdeepenings. We have the opportunity with the International Scientific Continental Drilling Program to drill in such an overdeepening. We drill 250 meters into the ground, and we drill the sediments, we recover the sediments that were deposited in such a glacial trough. And we expect that these sediments will tell us all information we need about the old ice ages.
Welcome here at the drill site in Basadingen, Schlattingen in the forest. Right behind me you can see the drill rig, which is in full operations right now. We are standing here on a flat surface, but below our feet we have about 250 meters of loose, unconsolidated sediments, which were left here after the glacier had eroded this big overdeepening and filled it with these loose sediments. The drill rig behind us is a specialized tool, so it goes down meter per meter and takes up samples. We call them drill cores. So we take these cores and look at the sedimentology inside, and that helps us to understand the geological history of the area that was formed by this, or is dominated by these glaciations that run onto this terrain repeatedly during these early and middle Pleistocene glaciations.
So after the drilling, we get the drill core in our core lab here, and we measure here, or we do some preliminary measurements here on this core scanner. We have some tools here. We measure the density, P-wave velocity, the magnetic signal, and the natural gamma radiation of the cores. At the moment, we can follow the live action, and live action the measure parameters. Right now, at the moment, we are at the depth between 130 to 139 meter, and we see here the different logs that we measure on the MSCL scanner. For example, in yellow there is the gamma density. And we can detect here if the cores are filled with sediments, also what kind of sediment, or if we have gaps, we can see clearly in the variation of the density. An interesting feature that we are measuring here is the natural gamma radiation log shown in light blue. It is used to detect variation in the clay content in the sediments. For example, these two peaks here may hint towards a higher clay concentration in the sediments, which is typically for glacial lakes that forms in front of the glacier during the retreat phases when it's get warmer, like in the end of the ice age or in a warm phase during the ice age.
After we scan the cores here, we're going to transport them to Bern. And there in the lab, we open them, we photograph them, we sample and analyze them, and we date them because we want to know what's the age of the sediments. Then we compile all the data for this drill hole, and from our colleagues who actually perform similar analysis on drill holes all around the Alps, we can compare them on a pan-alpine vision, all our results, and we get the view how, let's say, over the last million years, the glaciers left and retreated back into the Alps, how the last ice ages were looking here in the area. This is of importance for paleoclimate because we reconstruct how climate affected the ice ages. But it's also important how a landscape evolves because the glaciers, as we know now, they erode a lot. And this is important to know because we want to, for instance, for the safety of nuclear waste disposal sites, we want to know where and when do the glaciers erode again, so that, for instance, these deposits are not harmed by glacial erosion.